All around us, right now, we're swimming in a sea of invisible signals. Our phones, our Wi-Fi, our smart gadgets, they're all creating this kind of electronic smog. And yet, we love the convenience. But this invisible pollution, it's becoming a real problem. So, what if we could create an invisible shield to fight back? Well, that's exactly what we're going to dive into today.
Let's start with something we've all done a million times. You get on a plane, you settle in, and then you hear that announcement. Please switch all electronic devices to airplane mode. We just do it, right? No questions asked. But have you ever stopped to think about why? What's the real reason for that little airplane icon?
It all comes down to a problem called electromagnetic interference, or EMI for short. You can think of it as this invisible smog of electronic noise that all of our devices are constantly putting out. And it's not just some minor annoyance. It's basically a new form of pollution, and it has some surprisingly serious consequences.
All right, so to figure out how to fix this, we first need to get a handle on just how big of a deal this EMI smog has become. Because let's be honest, we are living in an incredibly noisy electronic world, and the volume is only getting cranked up.
So what exactly is this EMI smog? Well, it's pretty much what it sounds like. All the invisible electronic noise from every wireless device all jumbled up. This noise can cause all sorts of headaches, from data loss to making your gadgets just stop working right. And it affects way more than just our phones. It can disrupt mission-critical systems like military radar. And on top of that, scientists are now starting to look into the potential long-term health risks of being bathed in it 24/7.
Here's the kicker. This problem is getting worse, and it's getting worse fast. Our endless demand for faster data, 5G, 6G, whatever comes next, is pushing us into using higher and higher frequency bands. It's kind of like our current signal highways are totally jammed with traffic, so we have to build new super highways. The only problem? These new highways create way more interference.
Okay, so if the problem is getting bigger and noisier, what have we been doing about it? For a long time, we've relied on different kinds of shielding. But as you're about to see, the old ways of doing things just can't keep up anymore.
The old school solution was pretty basic. Just use metal. Wrap the important stuff in copper or aluminum. But think about it. That's like trying to put a medieval suit of armor on a brand new smartphone. It's heavy, it's bulky, it's not flexible at all, and even worse, it stops working well at those super high frequencies we need for modern tech. What we actually need is the exact opposite. An ideal shield that's thin, lightweight, flexible, and works even better at higher frequencies. This search for the perfect shield has led scientists to a really exciting, groundbreaking new class of materials. And honestly, their properties are so perfect for this job, it's like a superhero showing up right when we need one most.
They're called MXenes, and you pronounce that MXenes. Now get this, they're what's known as 2D materials. That means they can be made into sheets that are unbelievably thin. We're talking just a few atoms thick. It's wild. But their real superpower, the thing that makes them so special for this, is their incredible electrical conductivity. That's the secret sauce.
So just how much better are we talking about here? Well, take a look at this. This chart shows shielding effectiveness in decibels, and a higher bar is better. The traditional copper foil we've been using clocks in at about 60 dB. Graphene, another famous 2D material, hits about 35. But MXene? It just completely blows them out of the water at a mind-boggling 92 dB. This isn't just a little step up, it's a giant leap into a whole new league.
I know decibels can sound a bit technical, but what do these numbers actually mean? Well, the scale is logarithmic, which means every little increase is a huge jump in power. So at 60 decibels, you're blocking 99.999999% of the interference. Pretty good, right? But check this out. At 100 decibels, you're blocking 99.9999999%. It's basically the difference between turning the volume down and just hitting the mute button on all that electronic noise. So we already know that MXenes are incredible. But what if I told you a recent study took this amazing material and made it even better? Like record-breakingly better. By doing a little bit of chemical tinkering, basically swapping out some carbon atoms for nitrogen, researchers created a new kind of MXene film. And this new film reached an electrical conductivity of 35,000 Siemens per centimeter. Now that's just a crazy high number. To put it simply, they made it better at conducting electricity than any other similar material ever created. Period.
Now that record-breaking number isn't just about getting into the science history books. In the world of EMI shielding, it has a very simple, very powerful benefit. The more conductive your material is, the better it shields, and the thinner you can make it.
So what does that look like in the real world? Let's say you want that top-tier, 100 decibels of shielding. With the older MXene films, you need a film that was about 10 micrometers thick. But with this new, souped-up version, you get the exact same elite-level protection from a film that's only 5 micrometers thick. That's half the thickness, which is an absolute game-changer when you're trying to design the next generation of smaller, lighter tech.
So how in the world does this stuff actually work so well? It's basically a clever 3-step defense system. First, its surface is so conductive it acts like a mirror, reflecting almost all of the incoming electronic waves right back where they came from. For anything that manages to sneak past that, step 2 is absorption. The material basically soaks up the energy and turns it into a tiny bit of heat. But the third step, that's the real magic. Its unique structure is like a multi-layered accordion, creating an internal maze that traps and scatters anything left, making sure nothing gets through.
Right, so the key takeaway from the science here is that multi-layered architecture. It's not just a solid block. That complex internal maze is what makes the scattering so effective, and it's what gives MXenes such a massive advantage over a boring old piece of metal of the exact same thickness.
And look, this isn't just some fragile thing that only exists in a lab. This new material is tough. It's super durable, it barely showed any degradation after more than 230 days. It's also incredibly resilient, resisting corrosion in humid places where normal metal foils would just fall apart. And maybe coolest of all, it's versatile. You can literally spray coat it onto flexible plastics. This stuff is absolutely ready for the real world.
All of this brings us to one last, really exciting question. We are on the verge of having a nearly perfect electronic shield that's so thin, so light, and so flexible it could be built into almost anything. So, what does that future look like? Just imagine, smart clothing that protects you, drone skins that are invisible to radar, or maybe even transparent coatings on our windows that keep all of our wireless data safe and private inside. The possibilities are really just starting to unfold.